Hello and welcome. I am Sridevi from Hackveda. In this video, we will be diving into the fascinating world of building recommendation systems with a focus on countering bias. So let's get started. This is the agenda of the video. Firstly, we will have a quick intro to what does this fairness in personalized ranking mean. Then the importance of bias in ranking systems will be discussed, and then the data engineering techniques and algorithm development will be discussed in detail, followed by a quick demo which I have created in the Python. Then the limitations and future work of this task will be explained, followed by the conclusion. As we kick off, it's essential to understand the significance of countering bias in recommendation systems. Bias can influence the recommendations users receive, impacting their experiences. Our goal is to delve into the strategies that ensure fairness, diversity, and accuracy in personalized rankings. So, let's explore the impact of bias on recommendations. As already discussed, bias in recommendation systems can lead to unequal user experiences, perpetuate stereotypes, and limit exposure to diverse content. It's crucial to recognize the potential harm and actively work towards mitigating bias. By doing so, we create recommendation systems that serve users fairly and inclusively. So now let's shift our focus to the data engineering, which is the foundation of unbiased recommendation systems. Techniques such as ensuring diversity in the training data, data pre-processing, and fair feature engineering and debiasing strategies play a pivotal role. These steps collectively contribute to fostering diversity and fairness in personalized recommendations. Moving on to the algorithm development, we aim to create recommendation algorithms explicitly designed to be fairness aware, incorporating fairness constraints, striving for demographic parity, ensuring transparency, continuous monitoring, and establishing a user feedback loop are key steps in developing of robust and unbiased recommendation algorithms. Now, let's bring theory into practice with a hands-on demonstration in Python. So this is a Jupyter notebook in which I have created my model. As a first step, we need to import all the required libraries from the Python, after which I have declared the synthetic movie recommendation dataset here. Specific attribute contains y if this specific user likes the movie and contains 0 if that specific user does not like the movie. So this is a dictionary, as you all can see, and I've converted the dictionary into a data frame here. For those who don't know what data frame is, a data frame is a data structure that is provided by Python library called pandas in order to work with large data sets. So this is the part where I am splitting my whole data, which contains 15 entries, into test and train part. So here the train part contains the train dataset contains the 80% of my 15 entries, which are used to train my model, and the test part, which is the 20% of my dataset, will be there in order to test whether this model is correct and unbiased. So in this part, I'm simply creating a model using random forest classifier. So a random forest classifier is an ensemble technique method that is basically used in order to work with simple and small data sets. So I've created the model and I fit my training model into training data into the model. After training my model, as you can see, this is the output after which I've trained my model, and then I've given the X test data set in order to predict the Y values. So after predicting the Y values, I'm going to check the accuracy and the confusion matrix. So as you can see, the accuracy is up to 33.33%, which is actually very low. Since this is a user-defined data set, it is okay to get this type of accuracy, but in working with real time, it is always recommended to get 80 to 90% accuracy before moving forward. So as of now, we have created the model, and now we'll be checking the biasing, the impact of biasing in this model. So for checking the biasing, I defined the constraint here. So the demographic parity constraint is defined here, and I've given this in order to build a fair model to check the fairness of my model. I've then fit the data into my model. As you can see, here the evaluation is done, and then I've printed the evaluation. The accuracy of my fair model is 0.0. So since it's very obvious that this model is very much biased, that is why we're getting the accuracy as 0, and this specific model will not do well during the testing time. So yeah, that is all about the demo. Hope it is clear. So, as we progress, it's important to acknowledge that while we strive for fairness, there are limitations to current approaches. Bias mitigation is an evolving field, and our commitment to ongoing research and refinement is the key. Let's reflect on these challenges and discuss the potential avenues for future work. In conclusion, our journey through this brief exploration of bias in personalized rankings has covered key aspects by understanding the impact of bias, employing effective data engineering and algorithm development strategies, and acknowledging limitations. We move towards building recommendation systems that are not only accurate but also fair and inclusive. These are the references that I have used to accomplish this task. I have referred to an IEEE journal paper for which the link is displayed here. If you'll have any queries, you can contact me through my mail ID that I have specified here. Thank you for joining me on this quick journey, and remember, the pursuit of fairness is a continuous process. Stay curious and stay committed.